Welcome to today's lesson on functions. Functions is quite a fundamental topic when it comes to studying pre-calculus and calculus. First, two quick questions for you. How many friends can you have at any given time? Then students will say, we can have 20 friends, 30 friends, 35 friends. Then you ask them, how many friends do you have on WeChat? And they'll say a lot more. And you can give them the example. Barry can have Jerry, Terry, Perry, Carrie, Gary, and Mary as his friends. How many spouses can you have at any given time? Well, if you're in China, legally, you can only have one spouse. Spouse means the person you're married to. So in this case, Barry is married to Ari, so only one spouse, Ari. Now, can you have no friends or just one friend? Yes, if you choose to. Pop quiz, is Carrie a friend of Barry? Well, if you're paying attention, you'll remember that Carrie with a C is Carrie with a K. Nope. So, who is Barry's wife? Well, Ari, of course, right? Most students will remember this since we mentioned it last on this slide. And then we'll look at definitions. So what we can do is we give students a handout, fill in the blank notes sheet, I guess, where they can fill in these blanks for these keywords. So give them a little bit of time to fill this in, and then once they're done, you can explain definitions to these four keywords. Relation. Well, relation is a rule that connects two sets of numbers. In math, usually we work with two sets of numbers, inputs and outputs, but we can also work with objects or people like Barry and his friends as input and output. I mean, Barry could have no friends, one friend, or more than one friend. So here, S for plural, possibly. Function is a relation where each input has one and only one output. So Barry and wife, for example. Barry's input, only one output. Instead of all possible input, only one input. So Barry is the domain. Set of all possible input. Set of all possible output is called the range. Here, Ari in curly bracket means the set of. Okay, let's look at notation. When we talk about functions, there are three components: the input, or you can think of as Apple, the machine, say blender, and the output, say apple juice. So here, we can read this as f of. F bracket is f of. Here it's f of x. X for input, f of x for output. F of for the machine. So we mentioned you can have watermelon, blender, watermelon juice. The function machine doesn't always have to be blender. I mean, you can be creative, get students to brainstorm on their own. So think pair and then share. Or it could be like instead of pairing, they could go in groups of 3 or 4. Funny one could be breakfast you eat, your body, say this is your stomach, right, that digests, and then here people would laugh, is the waste that comes out. Once students have solidified this real life example situation, we can look at representation. First representation is a discrete case where a function is as a set of ordered pairs, could be graphed as 3 points, 1, 4, 2, 8, and 5, 7. Let's look at the domain. It is a set of all the possible input, so we draw arrow from the point shooting at the x-axis. It hits 1, 2, and 5. So put that in curly bracket, and that represents the domain. Same strategy for finding range. The set of all possible outputs, shoot arrow towards the y-axis from all the points. And you get 4, 7, and 8. And then put them in curly bracket, and this will be the range. Now, the order of these numbers doesn't really matter. I mean, you could have 7, 8, and 4 if you want. It doesn't make a difference. Here we have another way to represent the function using arrow diagram. You can see the corresponding pairs of 1, 4, 2, 8, and 5, 7. An analogy for this is, think of a vending machine. You have 3 buttons, button 1, 2, and 5. You have apple juice, orange juice, and grape juice. So if I want apple juice, I would press button 1 to get it. If I want grape juice, I'd press button 5. If I want orange juice, I press button 2. And the set of all the buttons would represent our domain. The set of all products or juices from the machine would represent the range. So how do we know if, given these 3 functions, if they're a function or not? Well, what we could do is we can go back to our definition of a function. It says a relation where each input has one and only one output. So to translate that for you, a relation where a machine, you can think of it as a vending machine where each of the buttons has only one and one product or juice. Meaning for each of the buttons that you press, you'll know exactly what juice you'll get. That's the idea of being a function. So going back to this slide, the first one, if you press button 3, you get product 8. So you know you get product 8 for sure. Button 6, say it's orange juice. Product 8 is orange juice. You know you get orange juice. Button 9, you get product 0. Apple juice. So you know what juice you get by pressing each of the buttons, so it's a function. Maybe product 5 is mango. You press any of the 3 buttons in this mango juice machine, you know exactly what juice you'll get. So yes, it's a function. Here, perhaps you have I don't know, watermelon juice and apple juice, but pressing button 2, you don't know whether you get apple juice or watermelon juice. So it's not a function. Let's look at the arrow diagram. And then can ask students about the number of input versus output. Here we can kind of see when the number of input is more than or equal to the number of output. In this case, there's more input than output. It's function. In this case, less input than output. That means at least one of the input will have more than one output. 2. So not a function. Domain is the set of all the buttons. Range is the set of all the products. And you can put them in curly bracket to denote the set of. First two are functions. The last one, not a function. Second representation. Students would be more familiar with function as formulas, as they'll probably have learned how to draw the line. F of x equals 2x minus 3. If you forget, this is y-intercept. Go to minus 3. Slope is 2 over 1. So starting from this point, 0 minus 3, go up 2 over 1. Up 2 over 1. You get 1 point, 2 point, 3 point. You get the line. Find the domain. Same strategy. Shoot arrows at the x-axis and then collect everything that it hits. In this case, it hits everything on the real number line. So we want to write down all the real numbers. Well, it's not possible for us to write them all out. So the idea is we just, for example, we can just write a symbol to represent this number. But if we just write this symbol x inside the curly bracket, the person looking at it would ask, well, what kind of number is x? Then to tell them that, you need to add some extra information by putting a line means such that, and then here you can write x is in the set of the real numbers. And then the person reading this would know, oh, okay, so x is just all the possible real numbers. Same thing for the same thing for the range. What are the range? You shoot arrows at the y-axis from all the points in your graph, and then you see that the whole y-axis gets hit. So you use the same idea. You use y as a symbol, and then you explain what y is. Y is in the set of all real numbers. So in this case, this is the range. Okay, let's look at the third representation. Function as a piecewise formula. So here we have a 3-piece graph. If the input is 0, the output is 1. So go to 0 on the x-axis, go to 1 on the y-axis, we get this point. The output is 2x minus 1 for positive x value means to the right of your y-axis you want to draw this line. F of x equals 2x minus 1. Starts from minus 1, not including this point, right, because it's not equal to 0. 2 over 1, 2 over 1, and then you draw this line. But you don't want the whole line, you only want the line that's this part, to the right of the y-axis. When x is negative, to the left of the y-axis, you want f of x is x squared, or the parabola. Here you only have half the parabola. What's the range? Well, what's the domain, I mean? Well, shoot arrow, you see that it hits the whole x-axis. Here if you extend the parabola, it'll keep going to the left. Here if you extend the line, it'll keep going to the right. So everything on the x-axis will be hit. Hence, x such that x is in the set of all real numbers. And that represents the domain. Range, same thing, shoot arrows at the y-axis. You see that everything above -1 is hit. Everything that's -1 or less, not hit. So you can write y such that y is greater than minus 1. I mean, you could add more detail by saying comma, y is in the set of real numbers. Right, put this here, y, and then this symbol, and then the R symbol. But often, by convention, we don't write it, and by default, people will say, okay, by default, we know y is real number, so we can not have to write that. Okay, so this is representation 3. Function test. How do we know, given a graph, whether it's a function or not? Well, it's called the vertical line test. You take a vertical line or a pencil and move it along the x-axis from left to right. If the vertical line never crosses more than one point, then the graph passes the vertical line test and represents a function. So here we have a line never crosses more than one point for this graph, so this one is a function. But here, if I just stop here, it crosses more than one point, so it's not a function. Here is a function. Now, given these three examples, we want to evaluate f of 1. What does that mean? Well, this is just saying, well, if I press button 1, what product do I get? If I give you the input of 1, what's the output? Right, obviously output is 4, or apple juice. Press button 2, I get orange juice. Press button 5, I get grape juice. Press button 7, where is button 7? There is no button 7, so I don't get anything. Right, apple juice, orange juice, grape juice, nothing, because no button 7. Students would be more familiar with this one. They'll plug in the input, and this is the rule, and you get an output. If you plug in A, it's just 2A minus 3. They can work this out. The third one, input is 5. Which case do we have? X is more than 0, 5 is more than 0, so you use this rule. 2 times 5, 10 minus 1 is 9. F of 5 is 9. 0. Well, use this rule, output should be 1. Minus 3 is less than 0, so we use this rule. Minus 3 squared is 9. And here, you're given input, and you have to find output. Keyword, evaluate. If we reverse this train of thought, given output, find input, usually you'll see the word solve. Here it says solve for the input, means if we tell you you have grape juice, what button did you press? 5, of course. Here you get orange juice, what button did you press? 2, of course. Here you have apple juice, what button did you press? Button 1. How about product 1? Well, I don't see product 1, so there is no button W. The way you can write it down, right? Button 5, 2, 1, no button W. Here it's saying, well, the output is 3, so you can put 3 here. Put 3 as the output, so 2b minus 3 is 3. Solve for b, the input, and it'll be 3. And you do the same for this one, and this one. And then students can go ahead and also solve this. If the output is 4, what's the input? I would recommend you show them how to do this graphically. So you can actually go back to the third representation. So we have the output of 4. So you draw a line, horizontal line, crossing 4. The line will cross here, go down, you get -2 as your input. The line will cross here, go down, you get 2.5 as your input. So you have -2 and 2.5. If you're given 1 as the output, use same thing, draw a horizontal line, you get here, cross, so -1, here cross, 0, here cross, 1. If your output is 0, draw a line here, oh, it crosses at 0.5. -1, no crossing, no input. Okay, so that concludes our lesson. Alright, 2 solution, 3 solution, and 1 solution, and then no solution for R. Students can work on the worksheet that we made. So after they go through the note, they can work on the worksheet, which will get them to review the basic idea they learned in this lesson. Now, because this video has to be a bit shorter, we reduced the time